What's up, Algebra 1 fans? This is Miss Duong here, ready for round 2. Continuation of activity 2.3.6. How many solutions? Well, as we investigated last time, a linear equation can have possibly one solution where x equals a number. Notice there's an x still there. No solution where the number does not equal the other number. Notice does not equal, no solution, does not work, does not pass go, does not collect $200. Oh, wait a minute, that's Monopoly. Or you can have an infinite number of solutions where the actual number equals itself. Notice that sideways figure 8, that's the infinity symbol. Okay. We're going to start with the given. Our equation is 10 minus x minus 6 equals 9x plus 4 minus 10x. I'm going to draw that line straight down through the equal sign, and I'm going to insert a 1 in front of the variable that stands alone to make it a minus 1x. After I found the given, I'm asking myself, can I distribute? But I don't see any parentheses. So then I'm looking for like terms. Notice the 10 and the minus 6 I've highlighted in blue on the left side of the equation, and the 9x and the minus 10x I've highlighted in green on the right side of the equation. Because remember, combining like terms would have to lie on the same side of the equation. Otherwise, I'll need addition or subtraction to move them from one side of the other. 10 minus 6 is 4. Drop down that negative 1x. And 9x minus 10x is also negative 1x, and I drop down the plus 4. Well, the left side looks awfully familiar to the right side. Oh, let's not forget our reason. CLT stands for what? Stands for who? Combine like terms. CLT. After we've combined like terms, well, what are we supposed to do? Let's think about the order of operations. What's that acronym stand for? Please excuse my dear Aunt Sally. Nah, I don't have an Aunt Sally. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. Just remember, when we're solving for an unknown, just like x, we have to work our way backwards. It's like taking off your shoes before you take off your socks when you get home from school. Alright, so I notice there's a plus 4. I'm going to subtract 4, but I must make sure that I subtract 4 from the other number on the other side. Notice I lined up the plus 4 with the minus 4. Hey, wait a minute. They both canceled out? Well, that's strange. I dropped down my negative 1x on the right side, and I've dropped down a negative 1x on the left side. Wow, these sides of the equation are starting to look more and more familiar. They're quite twinning today. What do I do with a negative 1x? Well, I can add 1x to both sides, but what will that result in? If I add 1x to the right side, I have to add 1x to the left side to keep that equation balanced. But a negative 1x and a positive 1x cancel out as well on both sides. So what am I left with? Not much. A whole lot of nothing. And what do I use to represent nothing? We use 0. 0 equals 0. How did that happen? Well, that is my solution, and I did simplify my solution as much as I could, getting rid of the numbers and getting rid of the letters by doing the inverse operation. It so happened to get rid of everything, so I'm left with nothing. But 0 equals 0 is a true statement, and it's always true. Therefore, I must have an infinite number of solutions.